addition reaction. Unsaturated hydrocarbon add hydrogen in the presence of catalysts such as palladium or nickel to give a saturated hydrocarbon. Catalysts are substances that cause a reaction to occur or proceed a different rate without a reaction itself being affected. Okay, here you can see that what is addition reaction? When an unsaturated hydrocarbon, here you can see that this hydrocarbon is what? Okay, unsaturated. Why we say it as unsaturated? Because here you can see that double bond is present. So such hydrocarbon or a compound are said to be what? Okay, unsaturated. Okay, because we have studied that what? Okay, if a compound contains double bond or a triple bond, then that compound are said to be a what? Okay, unsaturated compound. Okay, which we have already studied. That if a compound contains double bond or triple bond, then it is considered as an unsaturated compound. Okay, so here you can see that hydrocarbon which is used as a reactant, okay, that is unsaturated because double bond is there. Okay, when it get react in presence of what? Okay, nickel catalyst with whom? Okay, H2 with the hydrogen. Okay, so here you can see that hydrogen is added. Why it is added? Because here in this equation you can see that there is no elimination of any element is seen. Okay, during the reaction. During the reaction, not a single element is eliminated from the reactant. Okay, so as a product you can see that hydrogen which we have added, okay, they get attached with a given reactant and it will give a saturated hydrocarbon. So that is the sentence. Here you can see that. Okay, when a presence of catalyst such as palladium or nickel, okay, nickel and palladium, okay, as an here as a catalyst nickel is used. Okay, so it will give saturated hydrocarbon. Okay, and the use of catalyst is what? Okay, catalysts are a substance. What is catalyst? Okay, catalysts are a substance that cause a reaction to occur. Okay, they will pressure out a reaction to proceed to a different rate without a reaction itself being affected. Okay, they will not affect a reaction, but they will just pressure out or proceed a reaction. Okay, so that is the use of a catalyst. Okay, so this reaction is commonly used in the hydrogenation of a vegetable oil using a nickel catalyst. Okay, hydrogenation of what? Okay, vegetable oil using nickel catalyst. Vegetable oil generally have a long unsaturated carbon. Okay, as you can see that what? Okay, vegetable oil which are present, okay, they have a long unsaturated carbon chain. Okay, while animal fat have a saturated carbon chain. Okay, vegetable oil which have a long unsaturated carbon chain, okay, due to which you can see that for hydrogenation, okay, same reaction will be seen, but as a reactant we will take vegetable oil, okay, and we will hydrogenate it. Hydrogenated means what? Addition of hydrogen. Okay, so same reaction can be seen, but in place of reactant, okay, vegetable oil will be there. Okay, so long unsaturated carbon chain will be formed. Okay, so here this was our addition reaction. You must have seen advertisements stating that some vegetable oils are healthy. Okay, which we are seeing advertised. Okay, animal fat generally contains saturated fatty acids which are said to be harmful for health and which is also harmful for health. Oil containing unsaturated fatty acids should be chosen for cooking. Okay, for cooking what? Okay, oil which are unsaturated fatty acid. Okay, they are unsaturated fatty acid. Okay, that should be selected for cooking. Okay, purpose. Now substitution reaction. Saturated hydrocarbon are fairly unreactive and are inert in presence of a most reagent. However, in presence of sunlight, chlorine is added to a hydrocarbon in the very fast reaction. Okay, so here you can see that. Okay, hydrocarbon, as hydrocarbon we have taken methane. Okay, and we have chlorinated. Chlorinated means what? Okay, addition of chlorine. Chlorination, which we said is a chlorination. And chlorine can replace the hydrogen atom one by one, and it is called substitution reaction. Okay, and because one type of atom or a group of atom take the place of another, a number of products are usually formed with the higher homologous, okay, of a alkane. Okay, in this you can see that when a CH4 plus Cl2, okay, react with each other. Okay, during that reaction, what will be seen? One hydrogen will remove, so it will be CH3. Okay, one hydrogen from here, you can see that one hydrogen is removed. Okay, and in place of that hydrogen, chlorine will add. Okay, so CH3Cl. Okay, and that hydrogen which is removed, that will react with the another chlorine, and it will give what? HCl. Okay, it will give HCl. Once again I am repeating. Okay, what is substitution reaction? In substitution reaction, you can see that one element will substitute another element. Okay, and substitution, which you are knowing very well. Okay, one atom will remove, and in place of that atom another atom will take place. Okay, here in this reaction you can see that one Cl, okay, will take a place in this. Okay, so it will be one hydrogen is removed and one chlorine will form, so it will form HCl, and one chlorine which is remain, okay, that will react with CH3 and it will form CH3Cl. Okay, so this was the substitution reaction. So in substitution reaction you can see that one atom will add substitute another atom. Okay, so this reaction are said to be a substitution reaction. Okay, some important carbon compound, ethanol and ethanoic acid. Many carbon compounds are invariable to us, but here we shall study the properties of a two commercially important compound, ethanol and ethanoic acid. Okay, we will study ethanol and ethanoic acid. So the properties of ethanol. Properties of ethanol. Ethanol is a liquid at a room temperature. At a room temperature, you can see that it is a liquid. Okay. Ethanol is commonly called alcohol and is the active ingredient of all alcoholic drink. Okay, active ingredient for all alcoholic drink. Okay, so ethanol, which is the commonly known as alcohol and is a ingredient for the all alcoholic group as well as drink. In addition, because it is a good solvent, it is also used in the medicine such as tincture of iodine. Okay, for preparing tincture of iodine, alcohol is used, cough syrup and many tonics. Okay, many tonics, you can see that ethanol is used for medical purpose. Ethanol is also soluble in water in all proportion. Ethanol is soluble in water in all proportion. All proportion, you can see that ethanol is soluble. Consumption of small quantities of dilute ethanol causes what? Okay, drunkenness. Okay, and even though this practice is condemned, it is a social widespread practice. However, intake of even a small quantity of pure ethanol, absolute alcohol, can be lethal. Also, long-term consumption of alcohol lead to mainly a health problem, okay, which we are showing in the social activities. Okay, in the social activities, okay, you can see that alcohol play important role, okay, in the human beings. Okay, socially you can see that many persons, okay, are taking alcohol, and due to which a family has to face a lot of problems. So this was that health problem, and due to which you can see that many problem are seen in the health also. Okay, reaction of a ethanol, reaction with the sodium, 2Na plus 2CH3CH2OH, 2CH3CH2ONA plus H2. Okay, alcohol react with sodium leading to the evolution of hydrogen. Here you can see that what, okay, O here, from here H is removed, okay, and two molecule is there. So two hydrogen will remove, and in place of two hydrogen, two Na will take place, and we will get a product. Okay, so as a product you can see that sodium ethoxide is formed. Can you recall which other substance produce hydrogen on reacting with a metal? Reaction to give unsaturated hydrocarbon. Heating a ethanol at a 443 Kelvin, excessive concentration of a sulfuric acid result in the dehydration of ethanol to give ethene. Okay, so here in this you can see that what will be seen, okay, that from here, okay, from here OH will remove, okay, from here H is removed. Okay, so here you can see that CH2 is there, okay, bond CH2. Okay, so for satisfying both the, but here in carbon and in this carbon you can see that only 2 valency is set. Okay, so for stabilizing it we will what, okay, we will form double bond between them. So from this you can see that unsaturated hydrocarbon will form when a ethanol will react with whom, okay, H2SO4, okay, in presence of heat, okay, on heating ethanol, okay, and excessive concentration of a sulfuric acid, it will give this. Okay, so the concentration or a concentrated sulfuric acid can be regarded as a dehydrating agent. It's remove water from ethanol. Okay, it will remove what? Okay, water from ethanol. Now the properties of ethanoic acid. Ethanoic acid is commonly known as acetic acid. Okay, what the ethanoic acid is known as acetic acid. It belongs to a group of acid. Okay, as you can see, carboxylic acid. 5 to 8 percentage of a solution of acetic acid in water is called what? Okay, it is called vinegar, and it is used for preservation of pickles. Preservation of what? Okay, preservation of pickles. Pickles means what? Okay, in Gujarati we say it as a athanu. Okay, so the melting point of a pure ethanoic acid is 290 Kelvin. How much? Okay, it is 290 Kelvin, and hence it is often freeze during a winter in a cold climate. Okay, in a cold climate you can see that it get freeze. Okay, so this give a rise to its name, glacier acetic acid. Okay, so it is said to be what? Glacier acetic acid. The group of organic compound called carboxylic acid are obviously characteristic by the acidic nature. Okay, so in this you can see that carboxylic acid, okay, which is COOH group is present. Okay, and commonly we know it that if a COOH group, which is carboxylic acid, is present, then that group contain which type of chemical characteristic? Okay, it is acidic in nature. Okay, it is acidic in nature. Okay, so however, unlike mineral acid like HCl, which is completely ionized, carboxylic acid are a weak acid. Okay, so carboxylic acid are a weak acid. Okay, and here you can see that. Okay, one beaker is there, wire goes, tripod stand and burner. On heating it, you can see that reaction of ethanoic acid. Now, reaction of ethanoic acid, esterification reaction. Ester are mostly common formed by reaction of an acid and an alcohol. Ethanoic acid react with the absolute ethanol in presence of acid catalyst to give ester. So here you can see that what. Okay, ethanoic acid is there. Okay, ethanoic acid is there. Okay, when ethanoic acid react with whom? Okay, ethanol. Okay, when it is react with the ethanol. Okay, so what will be seen? Okay, from here OH is removed. Okay, from here OH is removed. From here H is removed. Okay, so OH and H, it will form H2O, and remaining amount, okay, will form CH3, CH3, C, C, okay, O, which is there. Okay, so that is COO. Okay, CH2, CH2 and CH3. Okay, CH3. So it will form ester. Okay, so this will be our reaction. Okay, COO. Okay, COO, C double bond O, as you can see. Okay, CO, CH2, CH3, esterification. Okay, double bond O. So it will form CH3, C double bond O, CH3, CH2. So it will be ester, which we say it as a ester, and the process is said to be esterification. So generally ester are sweet smelling substance. These are used in the making perfumes as well as flavoring agent. Okay. So in treating with the sodium hydroxide, which is a alkali, the ester is converted back to the alcohol. Okay, it will form backward to the alcohol and sodium salt of carboxylic acid. This reaction is known as what? Okay, saponification, which we say it as saponification, because it is used for preparing soap. It is used for preparing what? Okay, it is useful for preparing a soap, so it is known as saponification. Soap are sodium and potassium salt of a long chain of carboxylic acid. Okay, which we will study. Okay, CH3COO, C2H5, NaOH. Okay, in this reaction you can see that what will be reaction, as you can see. Okay, CH3COO, C2H5. Okay, on reacting this, okay, you can see that C2H5 will be formed. C2H5, O, C2H5. Okay, so in this reaction you can see that from here it will cut, so it will be C2H5, as you can see. Okay, O, which is also there, H, okay, which will form here, and O and A. Okay, so it will be what? CH3CO, CH3COO and A. Okay, so this will be your reaction. Same way, a reaction with the base. Okay, with the base you can see that what? Okay, CH3COO, H will remove from here, OH will remove from here, it will form H2O. okay, it will form H2O, okay. So as you can see, NaOH plus CH3 COO H, okay. So from here you can see that OH will remove, from here H will remove, okay. So it will form H2O and, okay, it will form H2O and Na will take place here. So COO-Na, okay. So this will be your reaction with the carbonate and hydrogen carbonate, okay. In that also you can see that ethanoic acid when react with carbonate, okay, so same reaction will be seen, okay. H will remove and Na will react with it. Now the soap and detergent, okay. This activity demonstrates the effect of a soap in cleaning. Most dirt is oily in nature, and as you know, oil does not dissolve in water. Oil does not dissolve in water. Okay, we know it very well. The molecule of the soap are sodium or potassium salt or a wrong chain carboxylic acid. The ionic end of a soap interact with water while the carbon chain interact with the oil. Okay, so in the process of washing also this phenomena can be seen. The soap molecule thus form a structure like a missiles, okay, here, okay, as you can see a structure like a missiles, okay. In Gujarati we say it as a door, okay, door cut, okay, dhoe tyara kapda, where one end of a molecule is towards the oil droplet, okay, as you can see, while the ionic end faces outside. These form an emulsion in the water, and the soap missiles thus help in the putting out a dirt in water, and we can wash our clothes clean. Okay, so here you can see that for closing a clean, okay, cloth which is washed, okay, during that you can see that dust particle with the water is removed, okay, that is said to be a missile, okay. Can you draw the structure of a missiles that will be formed if you dissolve soap in the hydrocarbon? Have you ever observed while bathing that foam is formed with difficulty and an insoluble substance calm remains after washing with the water? This is caused by the reaction of soap with the calcium and magnesium salt. Okay, what? Okay, when a calcium and magnesium salt is reacted with soap, at that time this phenomena will be seen, which cause the hardness of water, and due to which you can see that water get hard, and a hard water are very less reactive with soap, okay. It will not react, okay, when a soap gets scrubbed on it, okay, with a hard water. So hard water are very hard to react with a soap, okay. So this phenomena is because of that, and hence you need to use a larger amount of soap, and due to which we can see that lot of scrub can be seen, okay. We have to rub a soap very much, then it will give a foam or a scum, okay. This problem is overcome by using another class of compound which we said as a detergent, as a cleaning agent. Okay. Detergent are generally sodium salt of sulfonic acid and ammonium salt with the chloride and bromide ion, etc. Okay, so from this you can see that in detergent there are what? Okay, sodium salt is there of a sulfonic acid, or a ammonium salt is there with whom? Okay, chloride and bromide. Both have long hydrocarbon chain. The charge end of these compounds do not form insoluble precipitate with the calcium and magnesium ion in the hard water. Thus, they remain effective in hard water. Okay, so you can see that it is very effective in hard water. Detergents are usually used to make a shampoo and product for cleaning process. Okay, detergent which is used for what? Okay, shampoo and cleaning process. Okay, so this was the importance of soap and detergent.
And its compounds form an integral part of our lives. From food to medicines, from textiles to laboratories, These organic compounds find a place everywhere. We have seen carbon compounds having magical applications as well. Right from killing microorganisms to cleaning our clothes, they perform numerous amazing tasks. Did I just say cleaning our clothes? Where do organic compounds come into picture for cleaning clothes? Can you guess? That's right, in the form of soaps. Wait, what? Are soaps carbon compounds? Yes, they are. Soaps are chemically the salts of fatty acids. Let's understand this. Fatty acids are extremely long chains of hydrocarbons with carboxylic acid attached at one terminal. Now, since soaps are salts of fatty acids, they have sodium or potassium attached to the chain. So can you guess the structure? Let me help you with that. A long chain of hydrocarbons which can be saturated or unsaturated, and the chain will have a carboxyl terminal and sodium or potassium attached to it. The structure of a typical soap appears somewhat like this. How can they be represented though? Chemically, soaps are represented as RCOONA or RCOOK depending upon whether it has sodium or potassium attached to it. Now it's obvious that these kind of huge structures cannot be written precisely every time. That is the reason why we represent soap molecules using this structure. The ball on top represents the carboxyl terminal with sodium or potassium attached. This end is called the hydrophilic end or the head region. But why is it given such a name? Hydra is water as we know, and philus is loving. That means the end that loves being around or being with water. In contrast, this terminal is called the hydrophobic end or the tail region. Phobia, as we know, is fear. That means the group that fears being with water. It is the